Hi, good evening, and welcome to the True lecture number 7 in our 10-part series, which is my inaugural lecture series, and it's called Revamping Math, a Calculative Approach. We did one this afternoon that was half a lecture, so here's the full lecture. We get the whole 10 minutes, hopefully, unless there's an interruption. But we're going to talk about what we've been talking about this whole time, which is my theorem. It's called the two-sided circle theorem. A circle has exactly two sides to it, and those are 0 and approaching infinite. Yeah, so I mean, like, we could say that. So last time we were going heavily into the physics application because I said that, when light escapes a sphere, it's actually trying to it's coming up to an asymptote and gets bent around on the asymptote, and that's the calculus approach. So we're having a curvature of the asymptote or a shifting of the asymptote. We're running it out to a circle, blah, blah, blah. You get it, right? You get it. I don't need to hammer that home insanely. The only headway that I suppose I can make at this point, if I can rock my brain around it at this late hour, would be something, in terms of and it's too late to even think. I shouldn't be doing a lecture right now, to be honest, but I'll try to push through, I guess, because we got 8 minutes, but I should refer to my notes too. I mean, I was looking at my circle, and I was going back at my knowledge of the circle and how deeply rooted in pi it is, and how I prefer the diameter expression over the radius expression. The circle is a fascinating thing. Studying that shape in geometry is fascinating. And as it gets to a later hour, my creativity wanes and I become tired. So I'm not going to speak as creatively, but that's okay. And I honestly don't know what else I can talk about because I don't want to go into personal details of who I am at this point in time. Although many people watching this will already know me, but I mean, the point is I had this idea that I wanted to do something significant in, let's say, in math. Because what I want to do is I came up with this slogan. I want to invent theory for breakthrough technology. Usually we have breakthrough theory to invent technology, but I would rather invent theory to lead to breakthrough technology. And that's the true path of how humanity or a society or the economy or a civilization can progress on a macroeconomic level. So yeah, this whole idea of inventing theory for breakthrough technology is what I want to do. And I had to invent a theory. And honestly, I mean, I'm obsessed with the number 4, as I've mentioned, but, I've looked at different ways of evaluating the number 4 and appreciating the number 4 aside from music. And geometry was one of those ways. And I started off thinking, well, there's a circle, a triangle, and a square or a polygon. Anyway, the circle seems to be the most basic. And what are the properties of a circle? I got down to it. It's hard to really assess, but and I remembered something clicking in my brain of someone telling me one time, if you had like a polygon where the sides get smaller and smaller, it turns into a circle. And I thought to me, yes, that's exactly right. And probably a lot of people know that, but they don't know that it's not really about infinite or infinity, as you would say, like an infinite amount of sides. It's really about the asymptote and approaching infinite, which takes it directly to calculus and so on. And then, of course, you have the duality of having no sides or the 0 set and approaching infinite sides at the same time, which is my theorem, you could call it, if that's a theorem. I'm assuming it could be a theorem. I don't know what the technical definition of a theorem is. I guess that is a theorem and the one that has to be proven. And maybe that's really where all this leads. And maybe I don't even have the math skills to prove that possible. But, it's not something that's going to get done overnight. I've said to friends and acquaintances that this is a year-long project. So this thing about me giving lectures is just to start talking about it. So I have, first of all, a record on YouTube with the videos of me explaining what I'm doing, and second of all, so I can practice lecturing, and also third of all, because it's valuable to you. I think if I hope it is, anyways, someone watching, because we can think about these things. And I don't really talk to a specific type of crowd that would require, extraordinary vocabulary or extraordinary knowledge. I mean, knowing basic terms in math. I'm not even getting into calculus, really. I've mentioned limit and approaching, but I haven't even said the D word, derivative, once. So, because that is hella confusing. So, I mean, hopefully these lectures do find an audience or a home at the same time on the internet. That would be nice. I don't see myself doing too many more lectures after this series, to be honest with you. But it's something special that I wanted to do for these 10 lectures. And it's fun enough. It's fun enough. We have the ancient Greeks. I think it was Plato or something, or whoever had the dialogues, would have been Socrates or something, who spoke a lot, and his style was to communicate orally. There was an oral tradition of talking and passing through ideas, and that's what the lecture is really all about. I'm not saying that I am a philosopher by any means. I don't consider myself a philosopher. I actually detest philosophy. It's just not something for me at all. But for a variety of reasons, I prefer math. I prefer music and math. I prefer science, application, math, music, math, stuff like that. It's quite possible that I'll do some recordings on the piano at some point in the future. But as for talking, this could definitely be it for talking for lectures. I'm not going to bar me doing it again, definitely. But let's just say I want to work on the math side of this theorem if I can, and do some proofs for it, or a proof at least, and get that going. That said, there is the theorem, I suppose, and feedback. Oh, by the way, feedback is always welcome. Okay. Anyway, the theorem that I have stated was, so a circle, there are exactly two sides to a circle. And then that would be an open-ended theorem. And then the closed-ended, or more specific theorem, would be the two sides of a circle there are two sides to a circle at once, these are 0, or the null set, and the set approaching infinite. And then the proof would obviously be something along the lines of, well, first of all, it's a basic shape, so it has no sides or whatever. It's the one under a triangle. We get a downgrading order from polygon, which is 4, to triangle, which is 3, skipping 2 on shapes down to a circle, which is 0. That could be some kind of verbal proof. And then the proof for the approaching infinite is one we discussed of the hexagon, not the hexagon, the polygonal approaching infinite number of sides, which smooths out a curve. So there's some kind of proof there. That could be mathematical too, I don't know, or verbal. But I think what the essence of this theorem is, and the essence of the root of everything I've been driving at in this whole lecture series, and with the idea, is the following. I think it is the duality. It's the double nature of it. 0 and approaching infinite. Both of those sets are, in my opinion, similar, congruent, equal, of the same importance. They have a special relationship. And the circle is at the root of that. And that is exactly what I'm trying to say. And that will be the difficult part of the proof, if you think about it, because to prove a statement, to prove a theorem, you must address, I think, all of the aspects of that theorem. So to say, there are exactly two sides of a circle. You wouldn't just say, well, those sides are 0 and approaching infinite. No, you'd have to say why there are just two sides, and not more, and not less, or not greater than, not equal to. Why there are exactly two sides, meaning you must, I think, and I'm not really a mathematician at the heart of it. I'm just saying you would have to really say that there's a reason why there are two. there's a reason, and there is some kind of link between 0 and approaching infinite, and that's what I want to explore, and that's what the mathematical focus of my life in the next coming year is going to be something to that effect, and that will begin after this lecture series. Have a good night. Thank you for tuning in for the 7th lecture, and we'll see you tomorrow for the 8th lecture, and have a great night, everybody. Bye.